Test cross. The test cross is used to test something, actually. So it's used to determine if an organism with a dominant trait is homozygous or heterozygous for that trait. So for example, we looked at these peas a minute ago, and these are recessive, so it would be, I think we used R, so little r, little r. This one is smooth, so it's big R, I don't know, is it big R, or is it big R, little r? I don't know, but I'm curious. So I'd like to know what this is. So if I want to know, I could test this. So I could test to determine if an organism with a dominant trait, like this one, this smooth one, is homozygous or heterozygous. That's this or this. So how do I do that? The way that I do that is that I cross this guy, this unknown genotype, dominant phenotype organism with a homozygous recessive organism. So I take this one and it's either big R, or it's big R, little r. And I cross it with a homozygous recessive. That means little r, little r. So if it's this one, then I'm going to be setting up my Punnett square. And I'll have this one's gametes, which are big R, and this one's gametes, which are big R, little r. If you fill all that in, you'll notice that every single baby is going to be smooth, big R, little r. So you'll get 100% smooth, and you'll know, hey, this one must have been big R, big R. If it's this one, though, when this one makes its gametes, they separate out. You've got some gametes big R and some gametes little r. And then this one's gametes go here, and I end up with big R, little r, and big R, little r. And this one fertilizing that one gives me big R, little r, little r. And that one fertilizing that one gives me little r, little r. So I end up with 50% of them smooth, and 50% of the babies wrinkled. And I know, hey, the parent, this one that I didn't know must be this. So that's a test cross. So if the plant is, so anyway, I'm just doing that more formally here. So let's say the parent is big R, little r, and I think this is in your notes to fill in. You end up with offspring that are half smooth, half wrinkled. So, whoops. So the offspring are, the genotypes are either big R, little r, or little r, little r. And the phenotypes, they are round, sorry, they are, yeah, round and wrinkled, both. The genotypic ratio is 1 to 1. So one of these for every one of those, and same with the phenotypic ratio, 1 to 1. If it wasn't that, though, let's say it was the other one. Let's say it was dominant. This is why we do the cross. We want to see, is it dominant? So when this one makes its gametes, it's little r, little r. And when this one makes its gametes, it's big R, big R. Notice that this one's gametes went on one side, and this one's gametes went on the other side. And so you'll see that 100% of the babies are big R, little r. That means half of them, that means all of them are smooth. So the genotype, they are all big R, little r. They are all, did I do that wrong? They're all round, and they're all alike. Okay, and that's it for test crosses.